Hi to all. How are you students? Welcome to Srinivas physics classes. Today's topic is magnetic induction at a point due to finite current carrying wire. Due to the finite current carrying wire at certain distance I want to find out the magnetic induction. Let us see, listen very carefully. Okay, this is a finite current carrying wire. Okay, this one blue line. It carries some current I. From this, at a perpendicular distance capital R, I want to find out the magnetic induction B. B I want to find out. Then for that, what I have to do? I am going to apply the Biot savart law to find out the magnetic induction. When you want to apply the Biot savart law, at that moment, according to Biot savart law, this is a current carrying wire. On this, we have to take the small element dl, and from this at a distance smaller, the magnetic induction formula is mu naught by 4 pi into ideal sin theta by r square. Right, here I want to find out the magnetic induction, and due to this small element, right, at a distance smaller, the magnetic induction is dp. The dp formula is mu naught by 4 pi into ideal sin theta by r square. In order to find out the magnetic induction due to current carrying wire, we have to take the small element on the wire. Right, that small element length is dl. Okay, from the element at a distance smaller, I want to find out the magnetic induction. This is the formula. Okay, in this theta is the angle between the dl and r. Okay, right. Similarly, here also I want to find out the magnetic induction due to this wire. In this moment, what I have to do? Then I have to take the small element on the wire. This is the small element. This is the small element. Next, what I have to do? I have to join that element and point where you want to find out the magnetic induction. Here I want to find out the magnetic induction. You can join them. And this distance we have to take as smaller from the element to point where we are going to find out the magnetic induction. That we have to take as a smaller. Okay. And now the element is making some angle. Element is making some angle with the smaller angle is considered as that is phi. Okay, phi is the angle between what dl bar and r bar, dl bar and r bar, small element and r. Here this dl, red color one, that is dl is this length of small element. Okay, and now this element length from this wire, from the center, right, that I will take it as L. That I will take as L. Okay, and this is dl, this is dl, this is L. Okay, and from here I want to find out the magnetic induction. This is the point from the center. Let us take that as, now that is L. Next, how to find out this? Here I will take that angle as theta. This angle I will take as theta. This angle I will take as theta. Okay, and the lower end of the wire, okay, the lower end of the wire is making some angle. Okay, that angle I will take as theta 1. Okay, you can join the lower end of the wire, okay, and the point P. It makes some angle. That angle I will take as theta 2. Okay, theta 2. This is theta 2. And now the upper edge is making some angle. Okay, that I will take as theta 1. Okay, theta 1. Okay, I will rewrite the diagram. This is the magnet current carrying wire. From this at a distance capital R, I want to find out the magnetic induction. Okay, and the upper edge is making some angle, that is theta 1, and the lower edge is making some angle, that is theta 2. Okay, right. Here I want to find out the magnetic induction. Here I want to find out the magnetic induction. Let us see how to find out the magnetic induction. For that, what we have to do? Okay, and now let us see. First we have to take the small element is dl from the triangle, this one, from this triangle. Okay, magnetic induction due to small element, what we can write? Magnetic induction at point P due to small element of length dl is dB, right? The dB formula is nu naught by 4 pi into I dl sin theta. But theta is at here. What is theta? Theta is angle between the dl and r. But here theta is not there. Phi we have to write. I dl sin phi by r square. Distance is again r. Why here in formula we have the theta, but here the theta is equal to phi. Angle between the dl and r, but angle between the dl and r is phi here. That's why I dl sin phi by distance of point where we are finding the magnetic induction from the element is smaller. Here also distance of point where we are finding the magnetic induction from the element is again smaller. We can write the smaller. Okay. Now we have to change. This is according to Biot savart law we are writing. Biot savart law. Let us continue now. For that, what we have to do? We have to write the value of dl, formula for dl we have to derive. Okay, I want to derive the formula for the magnetic induction in terms of I and theta 1 and theta 2 capital R, and remaining terms I have to remove. Okay, right, listen very carefully. Okay, look at here. I am going to find out the magnetic induction at this point. Due to small element we wrote the magnetic induction. Then in this some terms we have to change. Then for that, what I have to do, from figure we can write something, right? What we know that we can write. From figure we write from this triangle. Okay, look at here. This is a triangle. Tan theta is equal to what we can write? Tan theta is equal to what we write? This is the triangle. Theta is angle this one. Tan theta equal to opposite side. Opposite side is L. Okay, by adjacent side, like this triangle is there, right? Look at here. This is theta, this is L, and this is capital R. Tan theta we write, it's a rectangle triangle, opposite side by adjacent side. L by capital R we write. From this we write L is equal to capital R into tan theta we write. Okay, here L we got. Then you can differentiate that one with respect to something, and then what you will get. Okay, and I am going to differentiate this equation with respect to theta. Then here we know L is equal to R tan theta. Differentiate above equation. Okay, when we differentiate above equation, what you will get? Right, let us, L differentiation is dl is equal to R is a constant, tan theta differentiation is sec square theta, and the theta differentiation is theta. Okay, this is the differentiation dl formula. You have to remember differentiation is dl. Okay, R is R constant, tan theta differentiation is sec square theta theta. Okay, or otherwise you can differentiate like this. L is equal to R tan theta. You can differentiate with respect to theta. dl by d theta is equal to R into tan theta differentiation is sec square theta, right? And this d theta taken to right side, then we will get dl is equal to R sec square d theta. We can do like this. Differentiate with respect to theta. Then when we differentiate with respect to theta, then dl by d theta is equal to R into tan theta differentiation is sec square theta. Okay, then from this dl is equal to, we will get as R into sec square theta d theta we will get. Okay, then after that here we got the dl. Okay, and this I will take as equation 1. This I will take as equation 1. Okay, and this I will take as equation 2. And then after that, from figure, one more thing we can write, that is, here you see from the same triangle we can write, okay, this small r I want to change into capital R because I want to express the B in terms of capital R. That's why from figure we can also write small r we want, that's why again sin theta we write, no, sin theta not, cos theta we write. From the same triangle, okay, cos theta is adjacent side capital R by hypotenuse small r we will get, means capital R by small r. From this, what you will get, the small r is equal to capital R by cos theta we will get. That means, okay, r by cos, 1 by cos is a sec, okay, in the mathematics it will be there, sec theta we will get, okay, right. Small r is equal to, we got as capital R sec theta. This is equation 3, let us consider, okay. And next, one more thing I want to write from the figure, right? From figure we write, it's a right angle triangle, look at here, this is theta angle, this is phi angle, and this is 90 degree, right? Sum of 3 angles equal to 180. That means from figure we write theta plus phi plus 90 is equal to 180. From this I want the phi angle, right? Phi is equal to, this 90 goes to right side, 180 minus 90 is 90, then theta goes to right side, then we will get phi is 90 minus theta, and this is equation 4, right? Now almost the derivation is completed. Now what we have to do, then we have to substitute the equation 2, 3 and 4 are substituted in equation 1. Then what you will get? Let us go for that. Then dB is equal to nu naught by 4 pi into I. dl is what? dl is r sec square theta d theta. Ideal sin phi we write as 90 minus theta by 4 pi, this is small r square. Small r is what? Capital R sec theta whole square, right? Now we have to simplify this. Then dB is equal to nu naught by 4 pi into IR sec square theta d theta, sin 90 minus theta is cos theta, by R square into sec square theta, right? This is sec square theta and this is sec square theta will cancel. This R and square also cancel. The next equation we will get is dB is equal to nu naught by 4 pi into I cos theta d theta by capital R. Okay, this we can also write like this, nu naught I by 4 pi R into cos theta d theta, right? Now this is the magnetic induction due to small element, okay, magnetic induction due to small element. I want the total magnetic induction due to this wire. Then how to find out the total magnetic induction? We have to integrate like this, many elements we have to take. Then if you integrate the small magnetic induction, then we will get the total magnetic induction. For that what we have to do? Just simple, it was very simple, listen very carefully, right? And now can I rub this and take the screenshot and note it? I am going to rub this. Right, let us see how we will get. Now total magnetic induction I want, total magnetic induction, that is B. Yes, how you will get the B? Integration dB. Integration from where to where we have to do, right? Limits what? The lowest angle is theta 2, highest angle is theta 1, okay. From this line, from the perpendicular line, above this line angle made by the wire is theta 1 and below this one line theta 2. This lower to, if it is taken as origin, lower to this is we can take as minus, upper to this we can take as plus. Then we write as the limits minus theta 2 to plus theta 1. The lower one, this side below, right, minus, above plus. Then we substitute the values, then B is equal, we will get as integration, the lower angle is minus 2, the lowest angle t theta lowest angle is below this is minus theta 2 and above is theta 1. We have to take the limits like this, and then after that we have to substitute the dB value. What is the dB value? Nu naught I by 4 pi r into cos theta d theta, right? dB we derived it here. Then after that, here the constants we have to write outside. Nu naught I by 4 pi r is a constant. Integration cos theta d theta. Right? That this is the limits we write here, theta 1 to theta 2. And what is the cos theta integration? The cos theta integration is nu naught I by 4 pi r into, right? Cos theta integration is sin theta. You have to remember it. Limits theta 1 to theta 2. Now this is minus theta 1. This is, sorry, limits are changed here. This is theta 1 and this is theta 2. Minus theta 2 to plus theta 1 are the limits. First substitute the upper limit. Okay, then b is equal to nu naught I by 4 pi r into, in place of theta we substitute the upper limit, that is sin theta 1 minus, we have to keep next sin theta 2, lower limit we have to substitute minus theta 2. Okay, instead of sin theta, here in place of theta first we substitute the theta 1, sin theta 1 we will get, later we have to keep minus, next in sin theta we have to write, but theta, instead of theta we have to write minus theta 2. Then after that, here sin of minus theta is again minus sin theta. There is a one formula is there in the mathematics. Then we will get like this the final formula. The final formula is b is equal to nu naught I by 4 pi r into sin theta 1 plus sin theta 2. This is the final formula, right? And this is equation 5. Very simple derivation. Okay, and now let us see here, since we can write the reason, what is the reason, what we are using it here, right? What is we are using it here? Sin of minus theta formula we are using. Sin of minus theta is minus sin theta, right? Okay, and this is the formula, nu naught I by 4 pi r into sin theta 1 plus sin theta 2. Okay, and this is the, actually one thing is that this is not in the syllabus, this is not in the syllabus, but this formula it is useful for us, that's why I derived. Okay, this is not in syllabus, no need to practice the derivation. Okay, not in syllabus, no need to practice. Okay, and now let us continue some applications of this. Okay, look at here, let us discuss some cases now in this. Now look at here, magnetic induction, this is a current carrying wire, finite length, it has some length. Okay, and at a distance, perpendicular distance capital R, at a perpendicular distance capital R, right? I want to find out the magnetic induction. At here I want to find out the magnetic induction. Then the upper end of the wire is makes some angle with this capital R, right, line, and that is theta 1. The lower end of the wire, right, when you will join the lower end and this point, it makes some angle with the capital R, that is theta 2. Then the B formula we already derived just now, B is equal to nu naught I by 4 pi r into sin theta 1 plus sin theta 2. Now what we have to do, right, this formula we can also write in terms of cos. Here alpha, here beta. Then with this formula will be written as nu naught I by 4 pi r into cos alpha plus cos beta. QMI is like this. Why we are writing like this? Because here we know from the figure, right, theta 1 plus 90 plus alpha is equal to 180. From that, if you want to change theta 1 into alpha terms, then we will get as theta 1 as 90 minus alpha and theta 2 as 90 minus beta. Okay, from the figure, theta 1 we will get as 90 minus alpha, theta 2 we will get as 90 minus beta. You substitute here sin 90 minus theta cos, sin 90 minus theta cos, then we will get this one. Okay, right. And now this case is very important. Okay, this formula is also very important. That only for the sake of this formula I derived that all things, and this formula we will use for the next topic. Okay, then let us see here. And here, magnetic induction at a point due to infinite state current carrying wire. Okay, now this is the infinite state current carrying wire. Firstly we took the finite, okay, and but here now we are taking the infinite wire. At this point I want to find out the magnetic induction. For that, what we have to do, we have to join this end and this point, then that will make some angle, that is theta 1. But here it is at infinite distance, okay, for example like this there, and then we will get some theta 1 angle. If some more distance, then more angle we will get. If some more distance, more angle we will get. Like this angle increases, but it is at infinite distance. Then in order to meet that, we have to go like this, right? And here also same thing. Then it is not at here to join like this, okay? And it is at infinite. That's why we have to go like this. Then the angles on both sides, the theta 1 and theta 2, the two are equal to 90 degree. And this is 90 degree, and this is also 90 degree. That means from the figure we write as theta 1 as 90 degree, okay, and theta 2 also 90 degree for the infinite straight wire. Then that's why, then we substitute this in above equation, then we will get the B formula as nu naught I by 4 pi r into sin 90 plus sin 90. Theta 1 90, theta 2 90. Sin 90 1 plus 1 2, right? 2 2 ja, it will cancel. Then final formula we will get is nu naught I by 2 pi r. This is the formula for B, right? Okay, you can simplify this, then you will get this equation. This is very important. This is very important formula. Magnetic induction due to infinite straight current carrying wire. That formula is nu naught I by 2 pi r. Let us go for one more case, that is magnetic induction due to semi-infinite wire. This is infinite wire. The both ends are not visible for us, okay, but here one end of the wire, this is the wire, one end of the wire is visible for us, but the other end is at infinite distance. Then this is the semi-infinite wire. Then for this, how to find out the magnetic induction at one end of the wire? Then for that, the lower end, how much angle it will make? If lower end is hit here, then some angle will be there, but the lower end is at here only, then that's why the theta 2 will become 0. Okay, theta 2 will become 0. For example, this is the theta 2 and this is theta 1. If this is not there, okay, for example here wire is up to here only there, then the theta 2 will be reduces. Wire is up to here only, theta 2 will be reduces. If the wire is at here up to here only, then theta 2 will disappear, the theta 2 will become 0, right? Similarly, then here semi-infinite wire means, then what we have to do, right? Then we have to take one angle theta 1 as here, theta 1 is 0, and theta 2, what about the theta 2? Sorry, downward angle is theta 2. Theta 2 is 0 and theta 1 is the upward angle. Upward angle. In order to join this infinite wire, we have to go in straight like this. Then this theta 1 is 90 degree and theta 2 is 0 at here. We substitute these all things in this. When we substitute theta 2 as 0, then we will get the B as theta 1 is what? 90 degree. Then substitute in this formula, B is equal, we will get as, in this formula you substitute nu naught I by 4 pi r into sin theta 1 plus sin theta 2. Then nu naught I by 4 pi r into sin 90 is 1 plus sin 0 0. Then final formula is nu naught I by 4 pi r, right? This is for the semi-infinite wire at one end, right? And the next one more, that is magnetic induction on the axis of finite wire. Case 3 we will take, that is magnetic induction on the axis of wire. On the axis of wire as shown in figure, right? As shown in figure. Look at here how to write this. Now this is current carrying wire. On this small element, current is right side. The small element we will take, the small element is DL, that is also right side. Okay, and this is the small element on the wire. This is the small element on the wire, right? Okay, its length is dl. And now here I want, this is axis. Axis means this is the axis. I want the magnetic induction at this point. I want to find out the magnetic induction at this point. Then you have to join the element and that point. The R is also, we will get like this. Okay. Then what is the magnetic induction? Okay. Magnetic induction formula in vector form, we know that dB bar is equal to nu naught by 4 pi into I dl bar cross R bar by R cube. This is in vector form, right? But here this we write is, or no need of vector form, directly we take the value, right? What is the formula for the magnetic induction according to Biot savart law? The dB formula is nu naught by 4 pi into ideal sin theta by r square we will get. Okay, ideal sin theta by r square. But from the figure dl bar parallel to r bar, okay, that's why we write as theta is 0, because nu naught by 4 pi into, we write ideal sin 0 by r square. Why we write sin 0? Because dl bar parallel to r bar. That's why theta is 0. What is r bar? R is the where you want to find out the magnetic induction. That point and element you have to join. This is small r, and dl also along same direction. Then when dl and r are parallel, then angle between the dl and r is theta. Then this theta is 0, you substitute, sin 0 is 0. Then magnetic induction we will get as 0. Right? On the axis there is no magnetic induction. On the axis, due to the wire, there is no magnetic induction. Okay? Take the screenshot and note it. And let us discuss one problem based on this and we will close. Okay, look at here. Let us go for the solution of this problem. A long wire having a semicircular loop of radius small r carries current I as shown in figure. Find the magnetic field due to entire wire at point O. Look at here, this is a straight wire. This straight wire contains one semicircular shape, and here we are asking to find, they are asking to find out the magnetic field at here. Magnetic induction at here we want to find out. Then for that, here magnetic field is there due to this straight wire, and magnetic field is there due to this straight wire also. Right? And magnetic field at O due to PQ and ST. Then in this PQ small element we will take that length is dl, and on ST also we will take the small element that is dl. And here for the PQ and ST part, dl bar parallel to r bar. R bar means we will take this one like this. Okay. Look at here. This is straight part. This is PQ part. Here I want the magnetic induction. This is a straight line. And on this small element we will take dl. And this distance is smaller. dl are parallel to each other. Then when dl and r are parallel, then what we will take? We will take theta as 0. Right? Then magnetic field at a point O. This point O is on the axis of this wire. That's why the theta is 0. Then the field on axis we will get as magnetic induction. Okay, nu naught by 4 pi into ideal sin theta by r square. From this we will get as B as 0. Okay, right. We got the magnetic induction 0 due to this PQ part and ST part, because this point O is on the axis of the wire. On the axis B is 0 already we know. Due to semicircular part we have to find out. For that we know already this is arc. If it is making theta angle, current carrying arc is making theta angle at the center. B formula is nu naught I by 4 pi r into theta, that we know. But here semicircular means how much angle it will make? It will make 180 degree. Right? 180 degree it will makes when we combine them. Then here magnetic induction, magnetic field due to semicircular wire, okay, QRS. What is the formula for that? Here the magnetic induction formula is nu naught I by 4 pi r, but the radius is smaller right here, nu naught I by 4 pi r into theta. But what is the theta at here? Theta is 180 degree. 180 degree is nothing but pi radians, right? Theta is 180 degree. 180 degree is nothing but pi radians, right? Thus we substitute here, pi will cancel. Then final formula what you will get here? Nu naught I by 4r we will get. Magnetic induction due to semicircular wire is nu naught I by 4r. Due to this part at here magnetic induction 0, due to this part magnetic induction is 0, right? Then total magnetic induction is at this point is only due to semicircular wire. Then the total magnetic induction, net magnetic induction, total magnetic induction or the magnetic field B is only nu naught I by 4r, right? This is answer. Okay, right. And I am giving one homework for you, right? Look at here, this is the homework, and find the magnetic field at point O in the following figure. Here we have to find out the magnetic induction. Try for this, and you have to use this formula. Okay, the formula also I will tell. Nu naught I by 4 pi r into sin theta 1 plus sin theta 2. This formula we have to use. Okay, try for it, and if you will get the answer, then you can send the solution to me, right? Thank you for watching my lectures.